Good morning. This lesson is for my Integrated 1 class, but before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this, but I'll title it how I title it in the title. But what I am sure of is I don't have any goals. Instead, what I have are formulas written on the board that we need to use to go over the Unit 7 practice test. So let's look at our formulas. And our first formula is going to be for linear pairs. Linear pairs are two angles that add to 180 degrees, and this is the equation that we get. Our second formula is for vertical angles. Vertical angles are angles that are opposite each other, and vertical angles are equal. So if you see this situation, set them equal. Now our next set of formulas are based on parallel lines being cut by a transversal. The transversal is a fancy way to say third line. Corresponding angles are angles in the same position. For this example, they're both on the bottom right, but they could be on the bottom left, they could be on the top lefts, or the top rights. But if you have corresponding angles and the lines are parallel, you know they're equal. The next angle pairs are alternate interior angles. Again, the lines have to be parallel. They're both in the interior and they're alternating sides of the transversal. So if you have alternate interior angles and the lines are parallel, those angles must be equal. The next type of angles are called alternate exterior angles. Again, the lines need to be parallel and they're in the exterior and they're alternating sides of the transversal. If you have alternate exterior angles, those angles must be equal. The last type of angles created are called the same side interior angles, where again we have parallel lines, both angles are in the interior, and now they're on the same side of the transversal. When this happens, the two angles we say are supplementary, which is a fancy way to say add to 180 degrees. This is the equation for this situation. And our final situation is our most recent lesson, and our most recent lesson taught us that the three angles of any triangle add up to 180 degrees. So I'd like to go over the problems with you, the 7 problems of the practice test, and make sure you understand how to set up the problems, how to solve the problems, how to answer the problems. All right, so here we go. Problem 1 and problem 2. The directions are find the value of x. So the first thing you need to do is you need to match up your picture to any one of these. And to me, number 1 looks a lot like this, except it's spun around and maybe reflected. So the equation that this is telling me is the two angles add to 180 degrees. These are my two angles, so they must add up to 180 degrees. Now I go about using my 6 steps to solve. Can I eliminate a fraction? No, I cannot. Can I distribute? No, I cannot. Can I combine like terms on each side of the equal sign? Yes, I can. So now we get 3x plus 30 equals 180 degrees. Are all my x's on one side? Yes, so I don't need to do step 4. Can I add or subtract away a number from the variable side of the equation? Yes, I can. I can subtract the 30 to both sides. So now I get 3x equals 150. Can I divide away a number that's with the variable? Yes, I can. I can divide away the 3. So that means that this value of x is 50. Okay. So that's how we would do problem 1. Now, you might be asked to find the angle measures, which means you would take the value of x, plug it in here, and that would give us 150, because 3 times 50, and 150 plus 2, that would be 152. But that's what I'm looking for in problem 1. Problem 2, match what we have to one of those. It looks like this to me. So I have vertical angles, so that means, that means my angles are equal. So 6x plus 2 is going to equal 44. All right, again, we get to our 6 steps. Can I eliminate a fraction? No. Can I distribute? No. Can I combine like terms on each side of the equal sign? Nope. And nope. Are all my x's on one side? Yes, they are, so I can't do that. Can I add or subtract away a number? Yes, I can. So I can take away the 2, and now I'm left with 6x equals 42. Can I divide away a number with the variable? Yes, I can. I can divide away the 6, And that means my x value, 6 goes into 42 7 times. So again, you might be asked to find the value of the angle. Well, x is 7, that gets me 6 times 7 is 42, 42 plus 2 is 44, and by the way, they're equal, which is what that said. Okay, and this one, again, let me point out, 152 and 28 add together to 180 degrees, so it supports the equation. So let me clean this up, set up problem 3 and problem 4, and I'll be back. I'm back. Let's go ahead and do problems 3 and 4. And remember, we have all we need to know over here. So what we need to do is match what we have up to it, set up the equation as it tells us to, and make sure we answer the question that's asked of us. So problem 3, I got 2 angles in the interior, and they're on the same side. So I have this happening. 2 angles in the interior, they're on the same side. And my equation for this situation when the lines are parallel is that the measure of the 2 angles add to 180 degrees. So that means the measure of these 2 angles must also add to 180 degrees. Let me find my marker. Here we go. So that means that x plus 75, that's one angle, x plus 75 plus x plus 115. These 2 angles, this angle and this angle, must add up to, not plus, but must add up to 180 degrees. All right, now I can get into my 6 steps to solve. 1, 2, 3, 4, 5, and 6. Okay, I can count. Can I eliminate a fraction? No, I cannot. Can I distribute? No, I cannot. Can I combine like terms on each side of the equal sign? Are there any numbers I can put together over here? And there are actually 2 pairs of numbers I can put together. My x to my x, and 75 and 115. So now I have 2 x's, and then 75 and 115, that gets me to 120, that gets me to 190, and that equals to 180 degrees. I'm probably going to forget the degree mark, not a big deal. All right, are all my x's on one side? They are, so I don't need to do step 4. Step 5, can I add or subtract a variable? Can I add or subtract a number from the variable side of the equation? And I can subtract a number. I can subtract 190 to both sides. All right, and now I'm left with 2x equals, if I have 180 and I take away 90, that means that I owe 10. My last step again is to divide away a number with the variable, and I'm going to divide away the 2. So that means x equals -5. 2 goes into -10, -5 times. Have I answered the question? No, I have not. I found the value that I need to plug in to answer the question. So this now becomes -5 plus 75, and that means that we are left with an angle measure of 70 degrees. So that's how we're going to do problem number 3. Problem number 4, same thing. I got parallel lines. I have angles in the exterior, and they're alternating sides of the transversal. So that means that I have this situation right here. All right. In my problem, the angles are there and there. But in the example, they're here and here. They're in the exterior, they're alternating sides of the transversal. This situation, when the lines are parallel, I set my angle measures equal to each other. So that means that I know that 15x minus 4 must equal to 13x plus 10. Okay, and again we get into our 6 steps to solve. Can I eliminate a fraction? No, I cannot. Can I distribute? No, I cannot. Can I combine like terms on either side of the equal sign? No, I cannot. Can I get all my variables to one side? Yes, I can. So in this problem, I'm going to move the 13x to the other side by subtracting it. It's the opposite. So now I get 2x minus 4 equals, is it minus 10? Oh, it's plus 10. Let me make sure I read that correctly. Equals to positive 10. All right, so step 5, can I add or subtract away a number from the variable side of the equation? Yes, I can. I can add 4 to both sides. So I'm going to add a 4. All right, and now I get 2x equals 14. And the last step is to divide away a number, and I can divide away a 2. So in this problem, my x value is equal to 7. And so I want to plug my x value into that. So now I get 13 times 7 plus 10. 13 sevens is the same as 10 sevens and 3 sevens. 10 sevens is 70, 3 sevens is 21. So that means that this is 91. 91 plus 10, that means that this angle measure is 101 degrees. That is my answer. Okay. So let me clean this up, come back with problem 5 and problem 6, and I will be back. I'm back. Let's go ahead and work on problem 5 and problem 6. And again, remember, we want to match what we have to the picture, and the picture will tell us how to set up the equation. We solve the equation, and we answer the question. All right. So problem number 5, I got two angles in the interior, and they're alternating sides of the transversal. That looks like this to me. Two angles in the interior, and they're alternating sides of the transversal. And the equation for this situation when the lines are parallel is that both angle measures are equal. So I will set each angle measure equal in this situation. So now we get 9x plus 4 equals to 8x plus 13. Okay, and again we use our 6 steps to solve. Let's see here. Can I eliminate a fraction? No, I cannot. Can I distribute? No, I cannot. Can I combine like terms on each side of the equal sign? No, I cannot. Are all my variables on one side? No, they are not. So what I need to do is I need to bring them all. I'll bring the 8x to the other side. I'll bring them all to one side. Okay, here we go. The 8x's on the right cancel out. 9x minus 8x means that I have 1x. 1x plus 4 equals to 13. Let's see here. Can I add or subtract away a number from the variable side of the equation? Yes, I can. I can subtract away the 4. All right. And now I get, let's see here. U cancel, 1x equals, let me write that correctly, 1x equals 9. Can I divide away a number? Yes, I can. Divide away the 1, divide away the 1. X is equal to 9. 1 goes into 9 times. All right. So I plug in my x value to that x value, and I get 9 times 9 plus 4. 9 times 9 gets me to 81. 81 plus 4, that gets me to 85. I kept stopping there, and I was trying to check the work in my head really quick. And so I was like, okay, I kind of figured the answer was going to be 9. I don't know why it bothered me, but this is 85 as we saw. Here, 9 times 8 would get us to 72. 72 and 13, that would also get us to 85. Remember, these are going to be equal. So you can check them out once you know the measures to make sure you did it correctly. All right, number 6. I have angles on the same side of the transversal, but one's in the interior, one's in the exterior. Well, I got exterior, exterior, different sides. Interior, interior, same side. Excuse me. Interior, interior, switching sides. Interior, exterior, same side. So we have corresponding angles of parallel lines. So what that means is they're going to be equal as well. So my equation is going to be 9x plus 10 equals 11x minus 10. And let's go ahead and use our 6 steps again. Can I get rid of fractions? No, I cannot. Can I distribute? No, I cannot. Can I combine like terms on each side of the equal sign? No, I cannot. Can I get all variables to one side? Yes, I can. I'm just going to move the 11x to the other side. All right. And now we have this canceling. If I have 9 and I owe 11, that means I owe 2, minus 2x. Minus 2x plus 10 equals negative 10. I don't know why I feel like I'm making a mistake on this problem. Make sure I wrote it down correctly. I guess I did. Alrighty. let's see here. Oh, and I didn't make a mistake. I did it correctly. Okay, so here we go. I did step 4 properly. Now I'm going to do step 5. I'm going to add or subtract away a number from the variable side of the equation, and that's the minus 10. Is that right? I feel like I got one thing wrong here. No, that's right. Okay. Okay, so minus 10, minus 10. All right, so minus 2x equals minus 20. Divide away the minus 2. And that means that we get x is equal to 10. I want to find the value of this angle, so I'm gonna replace the value of x with 10, so I get 11 tens minus 10. So 11 tens is 110, minus 10 gets me to 100 degrees. I don't know why I'm not trusting what I'm doing, because if I plug in 10 here, I get 90 plus 10, that's also 100, so I did do that correctly. I gotta trust my math skills, but it's okay to be cautious and make sure you're doing it correctly. Let me clean up number 5 and 6, come back with literally the last problem of the year. So let me clean this up and I'll be back. I'm back for the last time, I promise. So let's go ahead and do problem number 7, which I'm going to write down the 7 right here. All right, there we go. So we're going to find the measure angle A for problem 7. Here I have a triangle, and this is what it tells me about triangles. It says that the 3 angles of a triangle add up to 180 degrees. So that means that this angle, and this angle all together will add up to 180 degrees. So we get now the measure of, come on, let's do this right. We get 4x, sorry. You're not wrong if you write that, but you can say 4x plus 135, so we'll put degrees, plus 5x equals to 180 degrees. Again, the 3 angle measures add to 180 degrees, and we still use our 6 steps to solve. And I'm going to learn how to count one day. I'm just so excited to get this last section done. I'm making mistakes. Don't make mistakes. Go, think through, smooth, take your time. All right, here we go. Step 1, can I eliminate fractions? No, I cannot. Step 2, can I distribute? No, I cannot. Step 3, can I combine like terms on each side of the equal sign? Actually, on this one, I can. 4x and 5x, that's 9x. 9x plus 135, that's equal to 180 degrees. All right. Do I need to get all x's to one side? No, I do not. Can I add or subtract away a number from the variable side of the equation? Can I add or subtract something away from this side? Yes, I can. I can subtract the 135. Let's see here. So I get 9x equals 180. Take away 135. I gotta borrow, carry. That becomes a 5. That becomes a 4. That cancels out. So 9x equals 45. Can I divide away a number with a variable? And I can. I can divide away a 9. That means that x is going to be equal to 5. All right, so that means that my angle A, which is represented by 4x, is going to be 4 times 5, which is equal to 20. And if I wanted to calculate that just to make sure I'm doing it right, that would be 25. 25 and 20 gets me to 45, 45, and 135, that becomes 180. So we did find the correct measure for the angle A. All right, that does it for this year, this long, difficult year. We are done with video lessons and whatnot. I appreciate the effort that's made. I can't tell you how proud I am of those of you who made the best effort you could and put yourself in a position to pass. This has been a tough year. The rest of us, I know that we can do better. It's been difficult this year. Let's just look inward, understand what we could have done better, and do better the next time. I sincerely hope that everyone has success when we come back to school in person, and I think that'll be the case. Again, thanks for playing along. I really do appreciate it. Have a good day, everybody. Bye-bye.